Hello, in this video we're going to do a brief review of loops and how they are used in processing in Python, but more specifically we're going to focus on a pattern that we might see ourselves use loops with, likely. So here I have a very basic sort of boilerplate processing sketch where in the setup I set the background to be black and I change the size to be just a little bit bigger. Probably should make it a little bit bigger than that. Let's make that even larger. There we go. And then I turn off the stroke, which is the outline around shapes, and draw a circle. So the syntax to do a loop is something that you would reference in your reading, or perhaps the pocket reference, if you're trying to remember the syntax. But briefly, it takes two keywords and has two variables. The first keyword is the word for. The second keyword is the word in. And then we have the variables for some variable that we're going to make, which I'm going to use the letter I because that's pretty common. And then the second variable is the most important one, which is an iterator variable. And this is some property. This is something that can give us back a number of things one at a time. So most lists, sets, I think this number range function, there's a bunch of different features in Python that can sort of serve like this. And all they have to have in common is to have a person at the top of a water slide who can give you items one at a time. And the loop will just be like, give me the next one, send the next person down. Yeah, time for the water slide. So most commonly we use it with the range function, and we just ask for the numbers 0, 1, 2, 3, and 4. Other than that, the syntax is at this point like a function where we have a colon and then a new line, and when we indent, now we are inside of the loop. So inside of the loop, anything we type anytime we use this variable will have the new different value. Ooh, I said that poorly. So every time this loop runs, it will run the code inside of it over and over and over again before moving on to the next anything. And inside of it, this variable is what will be different every time this loop runs. Otherwise, it would just be the same code happening some number of times. So in our case, we can move this ellipse code into the loop. And if I were to run it as is, it would just look like a circle, which isn't very interesting. But if I use that I variable, then I can make it more interesting. So let's just try plugging that I variable in here and see what we get. It's just kind of a thing over to the side. Not very interesting. Let's try multiplying it by some number. All right, this is a 25 unit pixel radius circle. So let's move over 50 pixels. Draw the second one, move over, draw the third one, move over, draw the fourth one, move over, draw the fifth one, and I have 5 circles on the screen. And then we can offset that 100 plus. And we got 1, 2, 3, 4, 5. So that's how we might use this iterator variable in order to do something many times. But we may not need it. We might do something where we use a random number, like here, a random number between 0 and the width of the processing sketch, which in this case will be 500. And here, a random number between 0 and the height of the processing sketch, which again will be something between 0 and 500. And I got circles filling up the screen. Eventually, that'll fill it up all the way. Let's add one more line to our setup function, no loop. And doing that, 1, 2, 3, 4, 5. We're back down to just 5 circles in a different place every time we hit play. Great. So we don't have to use that variable. It's, but like we usually need to, because usually you don't want the code to run exactly the same every time. In this case, we're creating variation with randomness. Before we were creating variation with the variable. We can put loops inside of loops, which is a interesting thing to do. Often if we use I for the first one, we'll use J for the second one. And I'll do the range 5 again. Oops, where's my number there? I'm on a weird keyboard. And then we will choose the positions, 100 plus I times 50 and 100 plus 50J. Oh, missed the colon. There it is, and this needs to be indented. There we go. Hey, now we have a grid. So we loop, 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 and then the second loop runs, and then we go up, 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 and then the third loop runs, and we do, 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 and so on. Although I guess maybe technically, I think technically it would be going column by column if it were going in order. And yeah, so now we can, we can set this to be between 10 and 10, and then loop, more times, which is nice. But I'm probably drawing off screen at this point. So we want a little bit more control over these numbers. Instead of multiplying this number by 50 and adding 10 to it, it would be nice if I could just have it start at 10 and then increase 50 units every time. And that's exactly what we can do. So in the range function, there are three parameters. There is the stop, which from 0 until it hits this number, not including it, it will loop, but starts at 0, so that many number of times. But there is also a start function and a step parameter. I said function, I meant parameter. So we start at this number, we go until we reach this number, and we go increase by this every time. So by default, the start is 0, and the step is 1, which makes sense. Those are pretty reasonable default values. So if we add the 0 and the 1 positions here to define the start and the step, nothing changes. But let's say we want to move this code here, so we put the I and the J in. Now everything should be sort of pushed up in the top left. But I can increase my step. So I'll increase my step to 50, I don't know. And everything is in the top because I went from 0 to 10, stopped at 50. Let's go from 0 to the width and height of the screen. And we're back. And we're back to where we started. But we don't need to start at the, at 0, we can start further away from the top left. Boom, boom. And of course, I'm typing the same thing in both of these loops, but it doesn't really need to work that way. So easy way to make a nice grid. Could even increase this number. What does it need to be? Probably 25 units more to get up to the edge and include that little. I picked a width and height that's not like dividing evenly, so it's not like it doesn't quite look like a perfect grid yet, but whatever. Anyway, so that is one type of loop. For I in range, start, stop, step. The next type of loop is actually much simpler and much easier to work with, and it's just the word while. And much just like an if statement, which takes a keyword and then has a conditional, something that is true or false, and then it will run this code if that is true. While works the same way, but when it's done running the code, hello, please delete. When it is done running the code, it will go back to the top and it will check that conditional value again, and then it will keep going and it will loop and run the whatever lines of code are in here over and over and over again. So if we type while true, we're gonna break things. Luckily, we are in processing and we can just close it, and the Python infinite loop of running forever Python can be sort of terminated from the outside. But when I'm writing, desktop applications in C#, when I write a while loop, very likely that I end up crashing the computer. So let's make a new variable. I'm gonna call mine x because I already used I and j, and we'll set x equal to 0. And while x is less than some number, let's say 10, we'll draw an ellipse. But we'll change our fill color here. This is just an example. 255, 0, 0, which would be red. But that's a different topic. And the most important part of this is to increase the x variable so that eventually this thing will not be true anymore. See you. Probably should get rid of this code up here, but there we go. X times some number. There we go, and there's my red line. So that while loop is drawing a circle, drawing a circle, drawing a circle, and so on 10 times. So in the while loop, we needed some condition to be true or false. And then inside the loop, we needed to do something that would eventually change that condition. The other way we could do is that we have the words, break and continue, but another topic for another day to help us get into, out, and through loops in efficient ways. But as you can tell, if we have some if statement or a complicated function, and we accidentally never get to that point where we're like making the x variable bigger, that loop could easily go on forever and break. So we much prefer to use the for loop like 99% of the time. I used the while loop recently when I was writing a loading bar, and I was just every frame going, while is loading is still true, do nothing. And I sort of forced a loop to happen while it was waiting on something else somewhere else. So that's like a good example of a while loop sort of waiting for this unknown information to be completed. While in a for loop, you generally know the range, the iteration that you want to iterate over. So that is a review of what was covered in class on Tuesday the 20th, Wednesday the 20th. What day is today? So I hope that was helpful. And now I'm going to add one more feature that I know will be certainly helpful, which is often we don't want to, we're going to want loops, but we're going to want to do something with them every single time. And for that, we should make a function that we can bottle it all up with. So I'm going to draw a circle, and I'm going to move this ellipse code into here, and I'm going to call the function draw circle. And if I do, I will have immediately broken everything. Crash. No good. Because this I variable doesn't exist out here in this area. I mean, we did make it here, but it only exists inside of the for loop. We're sort of in this indent, in this scope, we get the I variable, but once we leave the loop, it's gone. I could make a different I variable, I could use it over here, but that's getting into scope. So instead, let's make some new variables and use those. And then here I will type I and j. So I take my data from the loop and I'm using a parameter to get that data into the function, and then I can have the function use all the complexity I want to, change the fill. Let's actually do random red, green, and blue values, or maybe HSV values. I forget which color Python uses, processing uses. Hey, random colors. Those might be random RGBs. I think we can change the color mode. What are colors? How do colors work? Great question. Bookmark it. Anyway, so we can add more complexity, if statements, do all this other random stuff, whatever we might be doing for our projects. And by wrapping that complexity into a function and giving it a nice name that's like very clear what it does, it says, okay, here I'm like trying to figure out okay, I'm looping, what's going on? I'm drawing a circle however many times. Here, whatever that draw circle means, it just means this stuff. And like functions are a great way not just to simplify your code, but to simplify your ability to think about your code and read it and figure out it and problem solve with it. So having things labeled what they're doing for the discrete like mental parts, even if they're not, even if this is just 2 lines, that might be just the more code all at once is confusing. Functions give you like built-in comments and labels. We love it. So I recommend using some functions for anything that you are repeating a bunch, sort of encapsulating that complexity into a function. unless it's, in this case, this is just 2 lines, but you get it. You're with me. You're writing code that's confusing and hard to read. One solution is just to make the code easier to read. The other solution is to, increase our mental model's ability to read the complicated code. But honestly, I'm a big fan of the former. All right. See ya.